at this point, right, so I was just saying you were curious about those weird little glitches that we're getting at the end, right? Those glitches, they, they're going to occur with Voronoi when you have a process like this because it's not perfect, right? You basically trimmed it down, which means that it's creating secondary geometry and it can't necessarily predict where the normals are going to be, right? Where's the first point and the end point of the line? So when it tries to create that extra surface, that's why you have this flip, right? You notice that the curve goes that way and then goes down here, right? So the flip is that you are going that way on one edge and you're going this way on the other edge. Right, so that's just one of those weird byproduct things. But we're going to fix that after we push it out into Rhino, or at least I am anyway. So one of the things that I want to do here real quick is kind of consider the fact that my Voronoi right now is very frail and fragile. It's okay. I think mine probably has a good thickness to it, but we'll test it out. But basically, if you take a look at this one more closely, what you're going to realize is that some of these little frame arms or spokes or whatever you want to call it have broken. And particularly around the part that was supposed to fold, there's some kind of like secondary folding going on. So if you want, take a look at that and just consider, just for now, consider the fact that materials have a certain integrity, right? And that integrity, when you stretch the limits of how thin you can make something, you know, it can bust pretty easily. So just something to consider. I'll put it over here. And so our final step here before we do a little test print to see the thickness of the lines is I'm going to bake this out. So I'm going to go to bake. I'm going to put it on whatever layer. You can create a new layer for it if you want. You can just put it on default if you want. Doesn't matter to me so much. Okay, and I want to point something out here to you. So in that particular condition that we were just looking at, it didn't even create the surface, right? So that's just an error, a bit of a glitch that sometimes you need to be prepared for to fix. Okay, so that one is very, very thin. A lot of these edges are going to be very, very thin. Okay, so my suspicion is that you can kind of fix that by creating another Grasshopper geometry. Actually, in fact, I think that's a good idea. I think that's a very good idea. So let's try that. Let's just try this real fast. So one of the things I'm going to do is let me turn off the other geometry first. And let me turn my original surface back on. What's that? Oh, I must have. Oh, I see. So I pulled the thing down, and those geometries are there. They just weren't connected. Doesn't matter. We can get rid of those. You baked it? I did, yeah. But I went back. I didn't like what I did, so I deleted it, and I went back into Grasshopper. So this time, what I'm going to do is I'm going to create another frame around the edge to give it some beef, right? It's going to be like a thickened frame that will actually give me some meat around the edge. Okay, so basically that's just going to be an offset curve, and I'm going to offset curve using the perimeter curves or lines, and I'm going to try going under curve, utility, offset, and I'm hoping that this is one of those cases that's going to immediately translate a surface into a curve. Let's try it. And it did. Okay, so it asked me for a curve. I gave it a surface, and it understood that what I meant was the perimeter curve of the surface that I gave it. Okay, so again, another pro tip for you guys, try those kinds of things out. You might be surprised. The offset distance is going to say how far. The plane is fine. We're working in the world XY. We don't have to modify that. And the corners are just going to define whether or not it's rounded. Okay, so let's not worry about the corners either, but we do want to define the distance. So I'm going to say 0 is less than 5.55, less than 10. I have no idea what size this is. I think 5.55 is going to be massive. So that's way too big. Oh, I'm going the opposite direction too. So I need this to be negative 10. Minimum of negative 10. Actually, it could go to the outside. It doesn't, well, no. No, it should not go to the outside. Sorry, I totally lied to you. It should not go to the outside. All right, so I just moved it 1 foot in. And if I turn now my surface for the Voronoi back on, now see that what this is going to do when I join the two, right? Because I have a curve that I'm going to, well, I'll need to create a surface for the frame first, but I have the curve that I'm going to trim out to create the frame, and then I'm going to connect the two. So, and it'll give me a frame around the outside. So let me get into this here. I'm working on the fly here, guys. We've got the curves as a list. It's one polyline curve. So I think what I want to do, let's see if we can do a trim. With a set of solid cutters. Nah, let's just do a surface. Let's turn it into a surface, and then we'll do a solid difference and cut the whole out.
Can I use that offset surface as, it's just surface, isn't it?
Offset surface is going to work differently. Offset surface is going to offset it from itself, in like it'll default to the z-axis. So it takes the same surface and it moves it to another place. I'll show you later. But we want to use offset curve because then we can do this. I can say surface boundary surfaces, right? So that creates another surface within my outer boundary. Here's where it's going to get a little crazy, guys. A little crazy. But you've already seen it before. We go to intersect, shape, solid difference, right? This is the second time we've used this. We take the original surface and we cut out. Did I do it backwards the other time? Yeah, I did. The original surface goes in the top, the cutout goes in the bottom. And so I'm going to turn these off. I'm going to turn my original surface off, and this is what I'm left with. Okay, this is significant because I need to now join these two surfaces. And that just looks like this. We go to solid union, also under intersect shape. And it's going to ask us for the B reps to union. So we can give one surface here. It's going to take a little while to calculate. And then we'll do the other surface right here. Again, it'll take a moment. And now when I select that, if I turn everything else off, oh, look at that. It didn't really do it right. Maybe it will when we bake it. That should have worked. Maybe region union. Huh. Join. Let's try B-rep join. Because what I'm seeing is it should have eliminated all this extra line work and surface in the frame. So I'm going to try a couple different types of joins of surfaces to see which one is the one I want. So I've got this solid difference I can plug in here. Let me turn this one off. And this one I'm going to plug in there. Flatten. No. Did you do offset surface?
No, it was offset surface.
All right. I'll take a look at it, but let me see if I can figure this out real quick. So flatten didn't work. I wonder, my thought is I had those weird surfaces that were shooting off the other direction. I'm wondering if maybe that's giving me an error. So what I can try is set list, and I'll list item it out. So list item. Which one is it taking? Okay, so I don't even have to do it because it's taking the original one I want. So I'll disconnect that. I don't need to give it a number. Reconnect that. Weird. That's very, very odd. Well, the good thing is if it gives me an error between these, I can take it out into Rhino and just do a merge all faces. I'm hoping that'll work. So I'm going to very quickly here just do that and close this thought before we move on to anything else. So I'll bake this one out, put it on layer 5. So it actually baked it out as 2 separate items. Which I should be able to Boolean union. And then merge all faces. Okay. So that did the trick. Solid union should have connected them, but maybe because there's not a merge all faces in here. Oh, there is. All right. Merge all adjacent coplanar faces into a B-rep. Let's try that one. And aha! Wait. Nope. Oh, maybe it needs to be flattened. Nope. All right. Well, I found a workaround at least, I guess. So that's what we'll do then. Let me go back here in Rhino. So basically when you bake this out, it's going to create 2 separate items. It'll create the frame and it'll create the Voronoi frames. So it's going to come out here as both of these. You yank it off, do whatever you got to do there, and you have to do 2 functions. You want to write these down probably. Boolean union to join them together. And then you need to select it again and do a merge all faces. Okay, so that will get you the final product. Okay, so I got a little confused there. I tried a few things out.
Like, okay, we make it offset, and after that we have boundary, and after that we're going to have a...
You want me to recap?
Yeah, please.
All right, so the objective, everyone, was let's just create a rigid frame around the whole thing that we're going to join with the geometry so that I don't have to worry about manually cleaning up all these weird thin edges and corners and, you know, graphic glitches and stuff like that. So I went all the way back to my original surface. I offset the curve, the perimeter curve of the original surface to give me a boundary which created a frame cutout. Make sense? So we created the reduced size frame. We cut it using solid difference so that it gave us a boundary frame that we could then
You delete join?
join. Yeah, I got rid of join. Any one of them will work. Actually, they all produce the same result. I'm sure there is a function that will do this correctly. I've exhausted the different types of solid joins that I'm aware of. So
we join that,
So I'm going to stop the video here and I'll come around and help you guys troubleshoot individually.